Another example of runtime error would be, let's say you have the list, right? List of cities. Pune, Mumbai, Bangalore. Let's say you have your console.log or print, you say. Try to access the element at the index which is not there. Let's say, for example, cities of syntax wise, there is no error. So your file will compile successfully. But when you are running the file, you will get this error. Which error? Cities of source. So there is no element at index 4. So you will say index out of range, index error, list index out of range. This is again an example of runtime error. So this is runtime errors. Now let's take an example of logical error. Let's say I have a salary of 10,000 and I got the hike of, let's say, 10%, and I want to calculate a total salary. The total salary, and I'll say here I will pass salary and I will return. I want to calculate total salary. So total salary into 0.10, 10% hike. And I call total salary. And I call the total salary with the, right, this salary. And I am printing this. And if I run this, this is giving me only 1,000. It should give me 11,000, right? Total salary would be. So this is a pure logical error, right? Which is basically happening because you have not written the correct code, right? This is logical error. You can fix it just by adding the salary to it. So calculating 10% and then adding it to salary. So this kind of errors are basically logical errors where there are human mistakes. Running it is fine. Answer would not be incorrect because of the logic, incorrect logic. Which error has to be fixed? So logical errors and the syntax error has to be fixed. But runtime errors can be managed. So runtime, so you can manage. Now here is a topic, right? Exceptions can be, so runtime errors, runtime errors, runtime errors, runtime errors, errors can be matched, can be managed by exceptions. Exceptions. First thing you need to understand why we need to manage the runtime errors. Because we want the program execution to be completed, right? We don't want my program to be hard in between, right? So example of this, what are exceptions? Then we'll come to the exceptions. We'll start the syntax for the exceptions, but why it is required. Okay. So for example, I told you before also that let's say I write something like this, print, and I say hello. And this line is causing me the exception, let's say 2 divided by 0. And then I'm printing by here. My execution will halt here only. And this statement is not executed. And when you see there is file or there database connected, I want certain code to be run anyhow, right? To basically avoid the corruption, right? But now here zero division error is happening. So after hello, it is not printing by because this line is causing the issue. So what is the takeaway from here? That I need to anyhow run this line because maybe it can cause me data harm or connection harm, anything. So I need to manage this, or it is not also good, right? When you are basically using an application, suddenly everything breaks, right? Because it's a clear execution halt, right? So we need to manage this by exceptions. Okay. Okay. So we need to manage this basically by exceptions. So let's try. So you have try block. So first example I'm taking. So program 7 will be just having a try and except block. So there is no catch block here, there is except block. So let's say I do try. So as I try, and I'm asking user a number. That's a integer input, enter number A. I'm storing that into number input, input is the number B, storing that into variable again. This line can cause error which I am writing. This can basically raise the exception. I'm saying print num1 by num2, num1 divided by num2. And there's an except block. So try has to always go with the except block. So I'm just raising an exception. Exception as E. Whatever the exception I get, maybe this is an inbuilt exception, I will be getting zero division error. I know the exception, but if you don't know the exception, you can just have the highest class. And the other exception basically implements or inherits this class basically. See, so this is a base class, right? So base exception have this exception class, and below this exception class, there are many exceptions like index error, index arithmetic zero division exception, right? But this is very generic. We have this generic exception as E, and I'm just printing the messages. And I'm saying E. Here I'm deliberately writing hello. And here I'm writing bye. So this is generic I have used, not to a particular exception. I am basically printing the message. This is the alias, and this will be the message which will I get when the exception will be raised. And I'm here writing bye. Now if I run this program, and if I put everything correctly, that's fine. 10 and 2, 4, let's say, I will get the output. But if I say 10, 12, and 4, see now, here it is 3.0. Okay, that is also fine. I need to run, so to raise the exception, so I will say 12 and then 0. And now you see, it will not halt the execution. Exception is raised from this line. So the control will go to this except block. This exception as E, I am just printing the message because this is an inbuilt exception. I will get this message 0 by error. And I am again continuing with my execution. So this way we can basically manage the exception. Similarly, we can manage it for the, what you say, for the list also. what problem we were facing in list. Okay. So let's move from here to the list. Let's say I'm here writing program 8. Let's say your A is 10. Let's say I'm having a list. This list is basically having 3, and I am trying to basically try to retrieve the element at fourth index. Here there is try colon. I'm trying to retrieve this index, and here is except block. So this except as E or except exception as E. If you don't want this alias, that's also fine. You can directly have your own message. Not many elements available. So because there is no, let's say again, for example, I am writing deliberately to show that the execution is continuing. I'm printing hello and here print y. So in this case also, if you see, if I right click and run this program, hello, 10, 10, 3, here, not many elements available. So this will basically cause the exception. I'm writing that in try catch. Once the exception is raised, it will basically come here and this statement will be printed. Now you need to understand when you get the runtime errors, you can basically call another functions and execute a different set of block also, right? Now there can be multiple errors or sorry, multiple runtime errors caused by one particular line of codes or snippet, code snippet. There can be certain particular type of error also. Let's say for example, now I'm managing two errors, two runtime errors in one program. Let's say if I come here and I have program 9. So the example I am having is basically now try except. Let's say for example, I'm starting again with the same printing hello, print hello, and here after print hello, what I need to do? I'm basically writing here try. Again, asking user for the two input, so it will be same. So this can be one exception. And then let's say I'm having a list, so this can cause me another exception. So now I am having two except block because I know which type of exception can be raised. So when this line will cause exception, the exception time will be zero division error. Zero division error. So I am basically finding that exception, printing the message of that exception, and also giving the message to the user, please enter correct input. Please enter correct input. The another exception which can be raised by this try block will be index error. So I'm basically raising index error, and I'm saying I will print the message of that inbuilt exception as it is, and I'll say not so many elements are available. To print so let's say if you run this 10 and 0, let's say 10 and 0 again. See, now the particular exception will be raised because there are multiple possibilities. When I put 10 by 0, this line would cause exception and the control will move to zero division error. So if you say it's saying, right, division by 0, please enter correct input. When this line will cause exception, right? Okay. Then the execution will go here. Let me just comment above code because I am getting that. Let me comment this. So now I'm trying to raise the exception from line number 68. So the control will go to the index error. If I right click and run, I put it correctly here this time. Number I entered correctly. See now, not many elements available, right? So list index out of range exception. So when this line causes exception, it moves to this block. Apart from this also, if there is any exception comes, we can basically manage it with the generic exception, which is exception as E, and print it. Let's say, for example, I am trying to print a variable which I have not defined. So there will be a type error. So Q3, let's say. So if you right click and run this, you enter the name correctly. You entered 4 correctly. Okay. Now this line is causing the exceptions. So let's make it right. Let's try to fetch the index at element 2. And there's an index at element 2, which is 3, right? So now if you right click and run this, let's say you have again hello here because you don't want to execute the, halt at the program execution. And let's say you have bye here also. So 10 and 0. 5. See. Now name Q3 is not defined, right? So it's a type error. Exception, what error is raised? Name Q3 is not defined. And then we move forward with Y. So this way, you can have one try and multiple except blocks to execute a particular code based on particular runtime errors. Is this clear?
Yes.
So this is 9th. Let's say we come to 10 now. Around 10. Okay. So there can be and finally block also. Okay. Whether there is exception raised and not exception raised, I want a certain set of value to be run anyhow. I want a particular program to be running anyhow. right? When we want such things to happen, then there is a different kind of exception. Okay. That exception is, I mean, when the exception is raised or not raised, I want any block of code to be executed anyhow. Then there is a finally block. For example, let's say, so now I'm writing the example for try, except, and finally. Obviously, this is optional. You can write it or you will not write it. It's the same thing, right? But if you want to run anything irrespective of runtime error is occurring or not occurring, you basically has the finally block. And this will make more sense when we start with the file handling topic. Let's say, for example, for the above code only, right? Okay, I will write it quickly. For example, print hello. And then I say try. And then I say pass. I'm not writing anything for now. And accept, pass. And then I will be writing final block. Say pass. So this is, let's say, the syntax. So syntax is what you have to try on something. If you found it, if some exception is raised, it will move to the exception and then move to the finally. If the try gets run successfully, there is no exception, then the finally block will be executed. Okay. So this, let's say, print. Let's say print by. So print 10 divided by 0. This will cause me the exceptions. So it will move to the 0 division error as E here. And I am printing that. Print. And this block will be anyhow executed. So I will say print I will always run. Let's comment this code. So this, let's say try, except, and finally. Now this will error, this line will cause the issue, right? Or you can take it from the user also. Copy. So this try is basically may or may not raise an exception. So I'm basically running it without exception. So if there is no exception raised, then it will basically print what is the division for the two numbers and will move to the finally block. If there is exception, still it will move to the except block and then finally block. This finally block, which is an optional block, will run whether there is a runtime error or not error, whether there is exception handle or not accept or not handle, right? So if I right click and run, I'm entering one value 10 and then I'm entering the value 5 and I'm running this. See, I will always run. This block is executed. And deliberately I'm basically having the exception here now. Let's say I make it like 10, enter, and let's say 0. Exception is raised, so it will basically say 0 division error. I will always run. I will always run. Irrespective there is exception or no exception, finally block will always run. Is this also clear? And before going to the user define exceptions, we can have another block in Python. You can have try, then you can have multiple except, then you can have else block, and then you can have finally block. So this way you can also have. So when there is no exception race after try and you want some other code to be executed, it will go to the else block. When there is no exception race, it will first go to the else block and then finally. So let's quickly have the example. So I will just copy paste the code for now here, which basically has the multiple try. Here, this is an example. And with the try and except, we can go the else block. If there is no exception race, it will go to the else block. Coming without exception. If there is no exception race, then this this block of code will run. Then this is both of these are optional, right? So I can add finally as a print. I am added and will always execute and will always execute. So now if no exception is raised, let's say, for example, I will deliberately create a situation where no exception is raised. And 5. So let's try to rerun again. Stop and rerun. Let's say no exception is raised. So I'm basically saying 10 and 5. So it will go to the else block and then to the finally block. Okay. But if there is exception raised, 10/0, it will directly jump to the finally block. So division by 0 exception, this exception will be raised, this message will be printed and directly to the finally block, else block will be skipped. So when there is no exception raised, then else block will run. This way you can have try, except, else and finally. Clear? Tomorrow we'll start with user-defined exceptions. We'll take 1-2 example of user-defined exception where you can have your own exceptions. Then we can quickly go for more 2 topics, which is assert keyword, and the last would be logging warnings. It's the code. Okay, thank you. Let me take the attendance quickly. Just wait for 1 minute. Thank you.
Thank you.